Hi everyone, welcome to the part 7 of a series of 6 videos on our codec. So this part shouldn't really exist. In fact, the previous part was already a little bit questionable. But so what we're trying to do with the previous part was we're trying to give an example of the usage of the new codec. But in reality, most of the work was really related to the new codec, which is PlantUML. And so we didn't really demonstrate a lot the sort of the ins and outs of the new style of development. We have a lot of videos explaining how to code using Dogen and Dia, but not that many with the new org mode codec. Now, the reason why we ended up doing PlantUML in the first place was because we're quite used to the graphical representation. As you can see here, this is the output that we now get from PlantUML. I mean, you can only see, since I only have one monitor recording, you can only let's double check. We are recording, in fact. Yeah, we are. So you can only see one of the two. Let me just open up in a single window. So what you can see here is the SVG output of PlantUML of our models, which is what we now use to visualize things graphically, as per from the last video. Now, this is not perfect by any means. We still have a lot of problems, like for example the relationships are not all coming through and so on, but at least it serves as a poor man replacement to Dia, just to give us some graphical view. And that's kind of what we did with the previous sprint. However, as I was trying to explain, it wasn't really very much a modeling video. It was more of just a regular coding video. So I don't think it was a very good demonstration of the new codec, and given we have so many of the Dia codec, it seems to me we should probably make a bit of an effort to explain the differences between the two. In addition, since the last video we made some changes to the codec, the OR codec itself as well, which made it a little bit more user-friendly perhaps. So what we'll do is we'll do one task using the OR codec that's actually more modeling. Well, it involves a bit of modeling, not like massive amounts, but a little bit. And so that task is to sort out the legacy Dia codec. So in the new world now, we have a codecs model. It's not very good because you can't actually see the names of the models from here. But in the new world we have, I wonder if I could just F11 and then control page up. And okay, right, this is not too bad. So as I was saying, in the new world, one of these guys here is going to be the Codec Model. One thing that is okay, we can do it. So logical model, identification model. So one of these guys here at some point is going to be the Codec Model. At some point, this is the logical model. I'm not entirely sure what's the best way to live in this new world. This is the guy I was looking for. So the codec model is the new way of doing things, and what we've done is we have this unified model that handles sort of all the codec related stuff, and the work of transforming, projecting between native formats and our internal formats is all done as part of transforms. And when required, projectors. We haven't actually needed it yet. And that's the sort of stuff you've seen last few videos, because you would have seen the org mode work and you would have seen the PlantUML work. And so that's all quite nice. But of course the problem is we still have to deal with the legacy stuff, and the legacy stuff is Dia now. Everything else has been done. And that's where we still have all these other kind of weird and wonderful ways of doing things. So we thought we'd get rid of that as part of the work of refactoring, just to make sure that we end up the sprint with a nice clean slate. We've tried to get the sort of Dogen in the best shape, the shape that most resembles the architecture, the target architecture, because the idea would be that from the next sprint onwards we're just going to focus on the sort of the actual, the real work, I guess, PMM work and so on, and the PMM work is going to target the architecture. So we really want the architecture to look as much as possible as a target. Otherwise you end up targeting the wrong architecture, as you can imagine. So the task then, it will be, one of the mop-up tasks will be to just get rid of this and merge this into the codec model. The first thing we need to do is we started off by creating this idea of a comment, I believe. And the comment is here. And the idea with the comment was that we were trying to capture some of the ideas we already had in processed comment. All these bits here. And we wanted to get rid of processed comment. So the first step is going to be to get rid of whatever it is that we're using at present, documentation perhaps. Indeed, documentation, as you can see here. So try to get rid of that, and then we will make use of the new comment concept inside of the Codec model. So this should really be a fair representation of the work in org documents. One thing that's worthwhile highlighting, so first let's get to the right model. So we need to open up the Codec model perhaps. And so one of the things that's worth highlighting is the new change that we've done in the last, since we recorded the last video. Now it's possible to have spaces in the headlines of work mode documents, and that still results on the classes with underscores. It's a bit of an experimental feature. We'll see how that goes. But that does mean that the documents are a little bit more readable. And we tried the round tripping, so as you can see here, it's still round tripping to the right name, so it seems to be quite useful. Now then, so what we'll do is we'll just locate. Now the good thing, so that's the first example of advantages of using this instead of dia. It's very easy to do Control S in Emacs, and once you Control S, you find the thing you're looking for, get rid of it, and that is it. So that's much better than what we used to do before. And now we can also look for all the elements that are making use of this concept, of this object template. It takes 5 seconds. Interesting. Comment itself is making use of documentable. Okay, right, it's not quite what you'd expect. Let's just go back. So we don't really want to have this sort of recursive relationships going on here. So let's just say that we have documentation, and documentation will go over to interesting original content. This is something we added recently as well. So as you can see, we just move this across, and that is it. That is all you need to do in order to move things around. And now we can also do autofill, which is very useful. And now we can get rid of documentable. So if we just now say, so as you can see, this was a very short example, but it is exactly for this that we worked so hard to get org, because this is really easy. Refactoring of a model now is just as simple as editing a text file, which is really easy. So all we need to do now is to generate, well, let's make sure we got the latest code generator. So over here. And if I now just generate all my org models, hopefully what you see is, as you can see, the documentation got removed. Although, oh no, actually that's fine, because these guys will be using comments, so that's fine. So that looks good. That also looks good. And element now looks good too. The model, right, let's just double check that the model itself has, right, the model is an element, so therefore it will be documentable. And also the other nice thing about this, of course, is so you finished updating your org model document, and now we can just simply do convert all plant UML and go to the browser, refresh, and as you can see, oh, I'm just about to say documentable has been removed, but that's not quite right. So that's the first stage. The second stage will be to generate all plant UML. Takes a little bit longer. Let me just show you what's going on here. Takes a little bit longer, and we don't really necessarily need to generate every single model, but Right, now then, if I now refresh, now you can see the document has been updated. So now there is no more the OCD nature of things where you have to make sure the document is in the right shape and so on. From now on, all of that is taken care of. Not the best of ways, of course. As you can see, this is not as nice looking as our previous diagrams. But what we can do in the future is we can learn more about PlantUML and positioning of elements and so on, and try to give some hints to PlantUML to give us the right outputs. And that's a lot less overhead than any of the approaches we had so far. So that was easy enough. Now what we'll do is we will just make sure, and as you can see here, the model got regenerated there. We'll just make sure that all of this makes sense, and I think it does, so I'm not going to bother too much with the details. Now, of course, if I try to run all tests, as you can imagine, this is going to break quite badly, because we are making use of the existing code. So what we'll do now is we will just have a quick look at where documentation is being used and make sure. Right, so where we are reading documentation, we need to make sure we read comments. We call it comments because we're following the die pattern. Probably not the best of names, but there you are. We'll just keep with that, and then we shall worry about it later. So here we just have to say something like entities and documentation. Comments, wasn't it? Comment. So read comments. Really not very happy with this name, but let's just try not to get too distracted with this, because names could always be refactored and renamed. It is not too hard. So all we need to do here is to make sure that we generate a comment, and then in here we could do something as simple as r.documentation is equal to that. The other thing as well is one of the reasons why we were very keen on making sure that sorry, let me just make sure I know what I'm doing before I comment on the state of the world. Right, so what we'll do as well for good measure is let's just go back here where we can see all the errors. Right, so what I was saying was we, as part of this exercise, we made sure via Frozen that we have all the JSON models, all the die models, and of course we also have the reference implementation. So there's a wealth of models that are using the existing codecs. So whilst we don't use them in Anger and Dogen anymore, these sort of reference implementation models, like things, including Dogen itself in the past, are still there, and they will break if we make a mistake. So I can refactor the JSON codec and the die codec with some confidence that we're not gonna, nothing is gonna get worse than it is right now, which is exactly what we wanted. So so we'll just keep going and see what are the problems here. Again, JSON codec, but the other end. So here we can just basically say comments.documentation.empty. So fairly straightforward changes. And we'll just keep going. So in theory, all that should happen here now is interesting. Oh, there you go. All that should happen here is okay. The problem is sometimes Emacs gets confused between fly make and fly check these days, and the actual compilation buffer. So when you say next error, it actually goes backwards because it's actually going towards the compilation error rather than the fly check error, which is really annoying, but that's what we have at present. I'm sure that if I spend some time trying to understand the finer points of how the errors work, we could solve this problem. But alas, we do not have time for all of this. So I suspect what we're going to now see is a lot of very predictable errors. They should all... okay, we are not quite in the right place. They should all be fixed very simply. Okay. And this is just the movement of the documentation to a different place. Now you can of course complain about naming and so on, and I understand that these are not the best names. We've been taking a lot of shortcuts with that on that front of late. It would also be nice to press the right keys. But we don't have the time at the moment to... well, we have to basically try to split the work into two efforts really. First, just capture whatever it is that we're trying to capture. And then second, try to make it better. I could probably make an Emacs macro right now. I should think, but just seems like we must be close to an end. Surely. Okay. At some point we're going to run out of errors. So what we really want is to get all of these things to go green. And once we got that, then we have comments and we have objects which look very much like the processed object and the processed comment we have here. And so what we can then do is we can get rid of process object and process comments, and then in the first attempt, first stage, we're going to, we're going to try to make use of the types in the codec model within the dia model, and then try to see how close we can get to the end result. And then we just move the types one at a time carefully. So that sure sounds all very straightforward. Right, so tests are green, so we could say codec codec.dia deprecate or remove documentation, use comment class instead. So maybe if we say remove deprecated documentation, use comment class instead. Okay, that's that one. Now let's see what happens if we try quite simply. Now there was a belief that the interfaces were almost identical. I can really see something like original content that I can't see here. Original content. Don't seem to have original content, to be fair. Ah, we do. It's part of the comment, so that's fine. Cool. So I think what we shall do is just remove these three types and then deal with the fallout. What should happen then is whatever we're calling one of these three types, we just have to call the codec type. And if we did a good job keeping the interface the same, hopefully, I mean of course there's a few differences, but we have to also remove this enumeration, but hopefully this will get us there. So let's try that then. Another good example of how easier now it is to do things is if we go up to codec.dia. Now you're probably going to hear me saying this quite a few times, but you have to remember we had this for a long time, so it is interesting from our perspective to see how much easier life could be. So processed object is just here, and what we'll do is just get rid of it, and then process comments is there, and then processed attributes. As you can imagine, these names are not the best names. Another reason why I need to get rid of them, and then we can just generate. I forgot to build a new code generator, which you should always do after every change. Now we just generate the models, and of course we still use building a diagram. Okay, so that built all the models you can see here. Everything was deleted as expected, and probably for good measure, let's just do a convert all platform UML and generate all platform UML. Again, what this is going to do is going to update all the diagrams. At some point we'll be bored of generating every single model when only one is changed, but here you are. All the tabs are removed, so that's what you want. However, now it's going to be a lot trickier than before, because you're going to get a lot of errors, and these errors are not going to be trivial. So okay, yeah, there is no such thing as processed objects. Right, so what we want to do is interesting. So the adapter is adapting between the old world and the new world. Now there is no such requirement as such. Now we need to adapt between an object and a class, I guess, an element, sorry. So I assume we are already returning elements somewhere around here. Oh yeah, okay. So what we'll do then is wherever an element, an attribute, we'll add an object, and we'll also add a comment. Wow, that's a good spread we got there. Pretty much everything that we could be adding. And whenever we see processed object, we just need to replace that with entities object. Now, I'm not claiming this is the best way of doing this, as always, but as you can see, there's going to be a lot of mismatches in this stuff here, but I think we just have to close our eyes for a little bit whilst we're going through the refactoring. Not much you can do, really. Right, let's just see then what happens. In fact, as a lazy person, it seems we should just, before anything else, just do the big replaces. It's going to be quite interesting that we're going to convert from A to A, but nonetheless. Right, so validate dia name cannot be empty, so presumably this is a simple name. And then what we need to do here is we could just say that the name is equal to the name. Simple. Now, what I was trying to say a second ago, which perhaps I didn't explain terribly well, is we are now converting between the codec model and the codec model. So there's going to be a lot of no-ops here, which is fine. We're not worried about that just yet. We will worry about that once we come to moving it to the codec model. So the first stage is just to get the code to compile and all the tests not to break. So in that sense, we will see lots of weird things, so that's fine. So what is the equivalent of an object type? So let's look at the codec model object. So yeah, there's a thing called object type. That's a string. So what we'll do is we shall, somebody must be doing a mapping between these guys. So processed object factory perhaps. Yeah, some mapping is happening here. So take this guy. just put it here for a second. And then we could just basically say if your type is UML class, so if your object type is UML class, or if your object type is UML latch package, okay, that solves the problem. Presumably this will just be all stereotypes, and this will just be all stereotypes. And not OO, just 1O. And away you go. So now then, if we look at the adapt method, 11 name, again we'll just go for the simple. Similarly here we can, well, to be honest, actually it makes more sense to just copy the simple because we're computing the qualified over there. Interestingly, we don't seem to be able to access the simple name. Interesting. I think we might have made a mistake a second ago. The object does not have simple and qualified name, just a name, which is correct. It's exactly what we want. So let's just double check that we didn't do anything very silly here. Yeah, I think what we really meant to say here was... Okay, well, the problem here, of course, is that this is an attribute, so that's fine. Let's just ignore attributes for a second. Focusing on objects, because objects do require a conversion, so that's why. Okay, so just copy a few things across. Now, child node ID is now become containing container ID, perhaps. And we can just process the stereotypes and the attributes. Okay, so actually let's just return to this view here, which I think is a bit more sensible. Right, so that's the adapter. Pretty much everything's going to break, so we can just open these guys one at a time. Right, so the builder will would have to go through similar refactoring. Well, refactoring might not be the right word, but so let's just do the usual trick here. Now I'd like renaming these guys to just O. It's also a good validation that we know what we're doing here. Let's see what happens in the codec. So same thing again. And then let's go through the methods. So mouse is always annoying. Are we an object? Here we are, container ID. Empty. There's no comments. Okay. And so on, right? Okay. Applicable to parent object. C is a comment. Applies to container, right? That's the equivalent. So we just map this and generalize the terms ever so slightly. Not a lot, but just a little bit. I think it's just sufficient that we could tell that they're not actually just a dia thing. And what we'll do is, again, we will, I think we might have this in the clipboard. Copy again those stereotypes, so those, this is not ideal, of course, as you can imagine, but it's sort of the first stage. At some point we'll have to generalize those things. So the object type is just a string. This is just other ID. This will be the container. Okay. And so this is not really a creative exercise as such. This is going to be very, hopefully, very straightforward, because we made sure that the interfaces of the types matched. Now the code that is going to result from this, of course, is not going to be brilliant, but that is not the point of the first pass. So if we just take this chap here and do the usual. Right, so what are we doing here then? We're taking one of these objects. Well, this one's actually quite effective. Okay, that doesn't look too bad. And just do that. Let's just look at the errors now. Okay, so is still referring to a processed object, not the header, interestingly enough. I wonder if this is just LSP getting a bit confused. Okay. So as you can see here, and as I said, this is not really the most creative of exercises, really. But also, it's a good way to, well, hopefully, we shall find that in a minute, but it's a good way to avoid breaking the world. Right, and then we have the object type, which, as we've seen already, is just object type, so that seems to have gone okay. We then have two interesting things. We still have traits here. I wonder if traits, let's have a quick grab. Is anyone using traits? Right, okay, so what we'll do with traits for good measure. Just create a copy of this guy here. We're trying to get rid of all these references to these badly named class traits. So we'll just get rid of it. This generates everything again. So hopefully we'll see traits being deleted as expected. So now, where we're making a reference to traits, we just need to update. So I'm actually going to go as far as keeping processed factories. More or less as is, in the interest of okay, that might not be the right choice. Right, so types, entities, comment, HBP, that's, oh no, that sounds about right. And then here we don't have traits anymore, one less thing to worry about, and if you could just, well, we're using string views here, but I'm just gonna bypass that for a second. Let's have a look at where we are using that. And this guy then becomes applies to container. Like I say, I'm sure that you're probably cringing with the amount of hack we're going on here at the moment, but that's exactly what we wanted for this first pass. It is not a problem. We shall just have to fix it as we go along. Okay, so the other thing we're going to do is, because we have a queue, these includes, perhaps we just do a quick place for these guys. So I want to rename objects. Okay. And then just for good measure, let's get rid of the P. And then oops. So there's the notion of a dia object and a codec object, and dia object is not the best of names either, so we need some kind of, well, okay, I'm just for now, let's just avoid having to fight too many words at the same time. Let's leave that as PO, and we will revert. We will deal with that once we get to the other side. So I never quite remember how to switch between lines in Emacs. Is it? Oh no, not quite. I have to really write down some shortcuts, I think, for Emacs. So parse attributes, we will do the same thing here. So this will be PO. Right, now then, let's do the includes. Right, so that didn't quite work as expected. So we don't really want object types because that's just going to give us problems. We do want these guys here. Building error is fine. And these are okay as well, I think. Though I'm not sure if we need to re-add the includes, but there you are. Right, so let's just try first broad session replace. Could probably cause havoc. No, this is a bad idea. Let's do this manually, I should think. Right, so first one. Processed object factory. You could spell. So we're doing for time. So we have done 38 minutes already. Let's try our best to reach some kind of a good state by the end of this. Now we just have to be extremely careful what we're doing here. Or at least the names are okay. Yet again, we'll have to copy, and we've done that already. So where were we? Right, so if processed object type is different from YAML generalization, return. I feel tempted slightly to just keep all the variables with the right name, with the existing names, but by changing the name, it does force you to look at the code again to make sure you're not doing something really silly. But if it starts causing too many problems, we might just have to give it a miss. So this is the attribute. Right, so I guess this would be something like simple. And I guess this would be this guy here. So if you think of this as a sort of a two-step exercise, all we're doing at the moment is we're just converging closer to the final result, really. That's the purpose of this first stage. although yeah, okay, that's fine because it's an object. Right, so where are we? I think parse object type is no longer required. I actually think this is going to be a no-op, so and then the child node becomes the container node, and we get that from interesting. That is slightly unexpected. Oh, child node. Okay, no, I think that's all right. I think if everything goes according to plan, I think that's all right. Okay, so kind of going according to plan. Right, so at this point in time, one would expect to see some kind of, well, a few compilation errors as expected, but okay, right now then, before we go any further, let's just have a look at who's using this mock process object factory, because sometimes we spend time fixing things and then realize this is some legacy thing that we haven't used in a long time. In fact, we don't really have a grep window, I don't think. Indeed we don't, so let's go to the area 9 perhaps. Let's just put this on pause for a second. Sorry, a bit of a to do with something, so let's go back to where we were. Where are we then? Oh yeah, we were about to run a grep to see if there is anyone actually using this. So the graph tests, which are useful, the adapter tests, which are to some extent useful. Okay, so we need to keep this. That being the case, we just need to look at the more process. I think this is probably fairly straightforward to fix, I think. Oh, and we did not do the validator, so let's just see what the factory is doing. Right, so what was that doing? Object probably. Right, so I think we could probably get away with the usual. Oh, no, we can't. But I'm actually just this time going to do a slightly more targeted replace. Still not that targeted, sadly. This means it's not going to work when we go to the other oh, yep, okay, that's fine. I think it's fine here. It's not going to be so fine when we go to the CPP because I think in here we are inside of, oh, okay, no, this is not the right namespace. So I wonder, oh, let's try to see what happens if I just replace some of these guys. Oh, no, that was fine. Cool, and now let's start by trying to find the ones with spaces on them. Might give us a good bang for our buck. And in fact, we don't need the word entities because we've put that in the path on the using that we're using for it. So right, create objects. They are object types. I think we should replace this with std string, I think. And that would just be the object type. The processed object will just become an object. So I'm tempted to just do a few big replace. Okay, there's always as you find when you become lazy, it's then when you realize actually it's a bit too late. You worry done all the replacements anyway. Okay, name. I'll probably become simple name presumably. Right, so in these guys here, hopefully we should be able to just remove the enum qualification. This will be slightly more boring because I think there's a lot of stuff here. Another thing I think we can probably get away with the big replace. Right, so I'm gonna yet again try to do a process object replace. Though I'm not, well, you know this is something bad's gonna happen, don't you? Sadly there's quite a few of these, so well, let's try something like that may give us a good bang for the buck. And child node ID, I think it becomes containing object ID something. Container ID. Okay. Okay, we still have quite a few errors. I thought these ones would have been taken care of. Perhaps we didn't do it high enough. Okay, so now let's just resume our area. Codec.dia. Codec.dia was it? Yeah. We just have to be careful to make sure we're in the right places because I think we're in tests. Perhaps not tests, but tests. Right. That's just a dot. Okay, so that's that guy. So the purpose of this video then will be just to finish the job here, get the test to pass, and then we'll call it a day. I think what we'll do is, I think to be honest, I don't think there's a lot to be gained now to continue showing you the rest of this task, or because a lot of the work now is just coding work. So that probably doesn't add a lot of value. What does hopefully have added a lot of value by now is you've seen how we handled the processing, the modeling aspects of the work. That I think is actually worthwhile demonstrating. And now you can see, of course, as well that we're doing a lot of hackery here because we're copying and pasting things, and this would all be hopefully handled once we get to the other side. So now here we just have to be very careful. Something like dot empty. So if we're empty, well, actually we just go with empty to be honest, because I think it's possible that the object type is not one of ours. I think we probably should have been, not sure if we should really validate against this list. Let's give it as a first go, not validate against this list. Or perhaps we should put fix me here. Should we check against the list of supported object types? And this is something that will remind us when we do the merge whether this should be done or not. Okay, so now then, the key thing now will just be the test, if I'm not wrong. And then, oh, look and behold, these tests have a bit rotted away. Okay, these haven't. Let's have a look at these guys here. Yeah, we definitely should want to get rid of these tests, to be honest. We'll leave it there for a second. Let's just deal with the ones we can deal with. So, This will be entities, objects IO. And then we just have to make sure all these guys are pointing to the right place. Should have a few copy and paste errors. Okay. Some of these tests are very old tests and are probably we don't really need them anymore, but it's not quite the time to make that decision. So applicable to parent object becomes what is the name of that thing now? Applicable to parent object applies to container. Okay. And this guy here would be simply something like that. Okay, that's that guy done. And hopefully we should be able to, not quite like the fact that we get a removal of the existing whatever you typed. Should really talk to the I should really talk to the LSB developers. That's not really ideal, because then I forget what I was trying to do with the include. It'd be nicer if it just added something and without removing all of it. Right, yet again, some more copy and paste jobs. Another copy and paste job here. And if we could just get rid of that enumeration. Finally, the child node ID becomes something like container ID. Okay. And a slight cleanup of the warnings. And there we go. Okay, now then, let's see what. So are we in compilation? Are we in the compilation buffer? We are. Something happened here. So we're just trying to get this code to compile. Okay, so we just moved one level up now. Let's see what happens here. This is a good sign. I think it means we compiled most of the code lower down. Oops, one too many. Yep, that's good. Okay. Then, as usual, I mean, by now you probably are getting a bit bored of my copying and pasting of this stuff, but I shall promise that we will fix that adequately once we get to where we should be. Okay, some kind of filtering going on here. Obtain entities. This looks very strange. Clearly destroyed this code. Now, we are not trying to fix all the problems of the world, so we will leave many things here badly named. That's fine. And that will be a subsequent pass. So this is just entities. Okay, so there's lots of stuff here. This must be some test case that we didn't touch yet. Right, so yet again another copy and paste job. We don't really need all of these guys here, but call me lazy. Now this may all seem very very poor practice, but I can assure you, at some point we shall. Actually, that's not a good session replace. Let's see. The best session replace for this is probably something like this. And then we can get rid of these guys here. Okay, so I think we are getting close to the end. And we're also approaching an hour, which is a good time to close this video. So okay, so hopefully if everything goes according to plan, I'm not expecting a lot of problems. I mean, if there's errors now, it's because we made a typo somewhere. We didn't. Right, cool. So that was a good exercise. What we've done is we got rid of a whole load of die-specific types. Process object. To recap, process object, process attribute, and all those legacy types I've gotten rid of. We're now using the types that are in the Codec model, slightly more sensible, and all these classes that are still here are now pointing to the other model. So then once that's done, we're not going to bother recording all that because it's going to be a bit boring now, and it's not to do with modeling really. Once this is achieved, what we then can do is we can go through each of these guys one at a time, try to understand what they do, and move them to their right place in the Codec model. And at some point we'll end up with basically nothing left in this model. So that was all for this video really. I just wanted to demonstrate how the new world works. In fact, I'm just going to demonstrate one more thing. Codec.dia remove process types. And what we'll do is, let's just double check the code generator is running from latest. One last task, which is to, in the Codec model, we don't really want to use object types anymore, so I'm just going to remove this type, generate all org, and then as good measure we just generate all plan UML, and then hopefully you can see here, I think we can commit all of these guys all in one go. And then if I just run all tests, it's going to pick up a few includes that are always a problem. These should no longer be used. Hopefully, are we in the right line? Object forward. Okay, more than includes. One method is still in use. So at some point we're gonna run out of errors. But yeah, that was just yet another demonstration of how easy it is now to modify the model. It's just like any other text file in org mode. Regenerate that, and then also we just regenerate this guy. Class gone, and where we go. So there we are. This is all for this video. Let's just say codec.dia remove dia object types enumeration, and there we are. So I'll just conclude the video here. Okay, thanks very much for watching.